All right, this is our notes for identifying a mineral, part 2. So we're just going to add to the previous notes that you took on color, streak, and luster. Today we're going to talk about looking at the crystal structure for minerals. This one's a little bit tricky for us because a lot of our mineral samples don't show the crystal shape that well, but it's still good because there are a few that are pretty good examples of the crystal structure. We said that when a mineral forms, that the atoms arrange themselves in a repeating pattern, and that makes a crystal. And sometimes you can see that crystal on the macroscopic, on the big scale for looking at the mineral. So you can see in these pictures here, those are really good examples of the crystal shape. And the reason they have that crystal shape is because of how those atoms arrange themselves. They're going to put themselves in this repeating pattern that you can see here. They're going to structure themselves in a certain way, and eventually if that pattern repeats and repeats and repeats and it grows large enough, then you would be able to see that crystal shape in the element or in the mineral itself. So there's thousands of different kinds of minerals. We said there's about 4,000 different kinds of minerals, but the shapes that their crystals take fall into about 6 different categories. You don't need to know all 6 of the types of shapes, but just be aware that, there we go, that there are some that form cubes. Sometimes you will be able to see that cubic shape. Sometimes you'll see like a hexagonal shape. Sometimes you'll see just different kinds of crystals. We're not going to get into, again, that a whole lot just because we don't see them oftentimes in our samples because they're pretty small. The second one that we're going to talk about today after the crystal shape is going to be cleavage and fracture. And those both kind of go together because they're both talking about how the mineral breaks. And cleavage is when you hit the mineral and it breaks on smooth, flat surfaces. So if you see smooth, flat surfaces like this picture here, that's going to mean that that mineral cleaves. The way the atoms are arranged, there's weaknesses on those planes where it breaks. So when you hit it, it's going to break where the atoms' bonds are weakest. And since they're on planes, that's what gives you that crystal, or excuse me, that flat, smooth sides. Some other minerals, when you hit them to break them, they just break randomly. They have rough, they have jagged edges. They're not going to have any smooth, flat sides. Now, when we do our minerals, we're not actually going to break them, because if I let you hit them with a hammer and break them and see, do they cleave, do they have smooth surfaces, or do they fracture and have rough, jagged edges? Because if I did that, I'd end up with a bunch of crumbs instead of my mineral samples. These minerals have already been broken off of larger samples, so we're just going to look at how they broke whenever they broke them and put them into our sample kits. So when you're looking at the mineral, you're going to be looking to see, does it cleave? Does it have smooth, flat sides? This one here, mica, is going to have a sheet cleavage, which means it peels and flakes off in sheets. So you can see here in this picture where there are strong bonds between these atoms, but then there's a weak bond between the sheets. And so that's where you're able to peel that apart, where that weakness is. Here's feldspar. This is another example of a mineral that cleaves. You can see it's almost at right angles here, but you can see those smooth, flat sides. The opposite of cleavage is fracture. And fracture is the tendency, again, to break. Sorry about my PowerPoint. It's kind of going crazy here. Is that it's going to break in rough edges. It's not going to have any weaknesses between the bonds. They're all equally strong. So where it breaks is completely random. That's what causes it to fracture that way, is the bonds between the atoms. Here are a few examples of minerals that fracture. This is called a conchoidal or shell-shaped fracture. This asbestos has a fibrous fracture, which means it kind of peels off in these little fibers. But basically, you're looking for something that has rough, jagged edges. So we're going to look here at these examples. Number 1 on your notes page, and add this to your notes. Just put number 1 under your cleavage and fracture section and say whether you think that that mineral cleaves or does it fracture. Then do number 2. Number 3. And number 4. And when you come back into class, we will check those to see how you did. The next property to add to your notes is going to be hardness. So when we do our mineral identification lab, we're going to be testing the hardness of different minerals. And the hardness is just how easily does the mineral scratch. How easily does it scratch other materials? So we're going to use different materials to see which materials it will scratch and which ones it will not. One of the things that we can use to test that is called the Mohs hardness scale. So you need to be familiar with the Mohs hardness scale. The Mohs hardness scale is 10 minerals that are rated from a 1 as softest to a 10, which is hardest. And they're listed right here in this picture. Talc is the softest. It has a hardness of 1, all the way down to diamond, which is the hardest mineral and has a hardness of 10. So we can use a kit for Mohs hardness scale that has each of these minerals in it, and we can take our mineral and scratch talc. And if it scratches talc, we know it's harder than a 1. Then we take it and we see if it will scratch gypsum, and then we know it's harder than a 2. And you can continue that process until you can narrow down the hardness of your mineral. Now sometimes you can't always get it exact, but you can narrow it down to a range for the hardness. Another way to test the hardness, or in addition to the Mohs hardness scale, is you can test your mineral to see how it scratches just kind of various common objects. So for example, a person's fingernail has a hardness of about 2.2 to 2.5. So you can take your fingernail, and if your fingernail will scratch the mineral, you know it's softer than a 2.2 or a 2.5. If you can't scratch it with your fingernail, you know it's going to be harder. Some other things that we're going to be using in class when we do our mineral identification lab is we will use a little glass plate, we'll use a steel knife, or excuse me, we won't use a steel knife, an iron nail, and we can also use a streak plate because that has a hardness of about a 7. So we'll be using those things to test and figure out the hardness. Once again, here's the Mohs hardness scale with the ratings for the different minerals that we can scratch our mineral with, see which one's harder. And here's some of those common objects. Oh yeah, copper penny, that's one of the other things that we will use. So we know if it will scratch a copper penny that it's going to be harder than a 3.5. So here's just an example. This mineral will scratch glass, so we know that it's harder than a 5.5 on the Mohs scale because a glass plate has a hardness of 5.5. If your fingernail will scratch it, then we know that it's going to be higher than 2.5. If it won't, if your fingernail scratches the sample, we know it's less than 2.5. There are a few other properties that we will look at that will help us identify our minerals during our mineral identification lab. That's going to be the density. We're talking about the density, the mass divided by the volume. Some of the minerals will be attracted to magnets, so that's another property that you can use to help you figure out what mineral you have. Some of them will bend light. Some of them will react with hydrochloric acid, and some of them have kind of a distinctive smell or taste. So we won't be tasting any of the minerals, but there is sulfur, which has kind of a distinctive rotten egg kind of smell. So there are kind of special little properties that can help you narrow down and identify your mineral. So those are our properties. Those are the last of the set. We'll be doing our mineral identification soon. Bring your notes to class tomorrow, and we'll check them and move right along. Thanks so much. See you guys tomorrow.